Imagine plunging into their atmospheres. Descending through layers of hydrogen and helium clouds, the pressure builds relentlessly. Here, familiar materials behave in alien ways. The key ingredient, carbon. In Jupiter and Saturn's atmospheres, it exists as methane gas. Colossal lightning storms shatter the methane, freeing carbon atoms for a transformative journey downward, pulled by immense gravity, pressure, and temperature climb. The destination, a precious state of matter. The soot is becoming crystal. The journey downward continues into the heart of the storm. The pressure mounts, squeezing the falling carbon soot. Under this titanic compression, the soot begins to change, their bonds rearranging into a more stable, more organized form. The black soot is compressed into graphite. The rain of graphite continues its fall. The temperature is thousands of degrees Celsius. The intense pressure forces the carbon atoms into a rigid, interlocking crystal lattice. This is the moment of creation. It has become a diamond. We are talking about a continuous, planet-wide rain of diamonds, falling through a sky you could never see, on a world you could never visit. Scientists estimate that the process could be creating as much as 1,000 tons of diamonds every single year on Saturn alone. They continue their descent toward an even stranger fate. The diamond hailstones, as large as your fist, continue their plunge through the deep atmosphere. Approaching the planet's deep interior, they encounter extreme conditions. The solid diamond crystals melt into liquid. Imagine, deep within Jupiter and Saturn, a layer where it literally rains liquid diamond. It's a diamond ocean, collecting deep inside. As this liquid diamond rain falls, it could influence the planet's powerful magnetic field. The patterns we see on Jupiter and Saturn are just the outermost expression of this incredible hidden world. See a world where diamonds fall, only to melt into seas of liquid treasure. This is the reality of our solar system, far more wondrous than we ever dared to imagine. Let us turn inward to visit Venus, a world that should have been our twin. It is nearly the same size as Earth, with a similar mass and density. For centuries, astronomers imagined it as a lush, tropical paradise. But Venus is not our sister. It is a vision of hell. The surface of Venus is the hottest in our solar system. What went so horribly wrong? The answer lies in its atmosphere, composed almost entirely of carbon dioxide. The planet is a victim of a runaway greenhouse effect, boiling away its oceans. This is a profound cautionary tale and a stark demonstration of how a planet's climate can be pushed past a point of no return, reminding us of the fine line between a garden and a furnace. Let's rewind the cosmic clock, back 4 billion years. In its youth, Venus may have been a very different world. Evidence suggests it could have been much more like Earth, a cooler planet with vast oceans of liquid water on its surface. The young sun was fainter then, providing less heat. Under these conditions, Venus could have been habitable, perhaps for billions of years. It's tantalizing to imagine a serene blue Venus, a true sister world where the chemistry of life might have begun to stir in its warm, shallow seas. But a slow, inexorable process was underway, a chain reaction that would seal the planet's fate. As the sun aged, it grew brighter and hotter, just as our star continues to do today. More solar energy reached Venus, and its surface temperature began to creep upward. This increased heat caused more water from its oceans to evaporate into the atmosphere. Water vapor, as it turns out, is itself a potent greenhouse gas. So, as more water vapor entered the atmosphere, it trapped more heat, which in turn caused the surface to get even warmer, which then caused even more water to evaporate. This is the beginning of the runaway feedback loop, a vicious cycle that, once started, is nearly impossible to stop. The cycle accelerated. A point was reached where the oceans literally began to boil away into the atmosphere. The entire planet was enveloped in a thick, dense atmosphere of steam. High up in this steamy blanket, the intense ultraviolet radiation from the sun worked its own destructive magic. The UV rays were powerful enough to split the water molecules apart, breaking them down into their constituent hydrogen and oxygen atoms. This process, called photodissociation, was happening on a planetary scale, systematically destroying the world's supply of water.